So today we're going to start learning about matrices. I don't remember if you did them with the new Algebra 2 curriculum, so you might not have seen matrices before. So just to make sure we're all on the same playing field, because I know some of you came from Algebra 2 2 years ago, some of you came from regular Algebra 2 last year, and some of you came from honors. So we're going to talk about matrices as if you have no idea what they are, and then we'll go on from there. So getting started with our matrix. So first of all, matrices are going to have these square brackets on them. Okay, so with them, we will have matrices that have a specific order. And so M means that's how many rows I have. And then N would be the number of columns. So, for example, if I have a 2 by 3 matrix, what that means is that I would have a 1, 1, because the first number with the subscripts denote what place it's in. So the first one's going to tell me what row it's in, the second number is going to tell me what column it is. So then I have 2 rows, so then I would also have a 2, 1. But I have 3 columns, so we'll do this pattern for 3 columns. So I'd have A, 1, 2, A, 1, 3. I would also have A, 2, 2, and A, 2, 3 in this 2 by 3 matrix. And so the IJ tells me what different pieces are. So if I tell you that A11's number is 2, you'd have a 2 in that location. This helps us go through and identify the individual pieces as we use it. And so for matrix shorthand, we often use AIJ. So what that means is if I tell you that A is a 2 by 3 matrix, I also could have said use some shorthand notation as well. So let's go ahead and get some terminology. So terms-wise, each element or entry, okay, that's that A11, A12, A23, all of those pieces come into play. And so the row subscript are the ones that are sometimes used with I's, or it's that first number in the subscript. And then the column subscript is often used by J, okay? And so the order of the matrix will be given as MN. And so the order is just telling me how big it is, how many rows, how many columns, how many pieces do I have involved. So if you still need more information off this slide, pause it and go on and move to the next part. So with this particular one, let's talk about just the order because that's what it's asking me to do. So with that, I have let me change away from the highlighter. I have 2 separate rows, so I have 2 rows. But then I have my 3 columns. Columns. So because of that, this matrix order is 2 by 3. Okay, so the order you write those two do matter, because otherwise you could have mixed up how many rows and how many columns I have, and that makes it kind of hard to talk about different pieces. So now that we kind of know what matrices are, we know how to identify the order, let's talk about adding and subtracting matrices. So to add and subtract matrices together, they have to be of the same order, okay? So you cannot add and subtract them if they are not the same order. That answer would not exist. But what we do when we add them is I'm going to combine like terms and only add those. So for example, when we had a vector, which is actually a type of matrix, it's just smaller, with a matrix, we would add the same components when we were adding in the vectors. We're going to do that now with addition and with subtraction. The order does matter in subtraction because negatives matter, Okay, so let's go and do an example and see how these work together. So we're going to start with an example of adding. Okay, so I'm going to write this with a lot more work involved. I know we know how to add, but what if you add wrong? I can't see that unless you show me your work in your steps. Okay, so I'm going to use multiple different colors in order so that you can see which ones are which. Okay, so getting started, I'm going to go ahead and write one big matrix so I can have lots of space, and then I will write a separate matrix once I've simplified. So my final matrix, because both of these are 2 by 3s, I have 2 by 3 slots. Okay, so these over here are a little bit bigger size-wise because I need space to show my work and what I'm adding. So for my first matrix, I have a 1 in the 1, 1 spot, and in my second one I have a 2. So I'm going to add 1 plus 2. Well, 1 plus 2 is 3, so I have 3 in that spot. So in the first matrix I have a 2 in the 1, 2 column, so I will have 2 plus the 3 that's in that second column. 2 plus 3 is 5. And so in the last column I have 3 in the first matrix plus 4 from my last one. 3 plus 4 is 7. Okay, I'm adding as a reminder because these are added in the middle. That caught some of us on our vector quiz because we didn't pay attention when it was adding versus dot product versus subtracting. So pay attention to what you're doing. The notation between them tells us what we're doing. So with that, doing the last row, I'm going to have 4 plus 5, which will equal 9. And then I'm going to have 5 plus 6, which equals 11. And then I will have 6 plus 7, which equals 13. So if you caught on, yes, this matrix had a pattern, but that's because both of the matrices I gave you to start with had a pattern. When you add them together, there's not always a certain pattern or trick to them, so don't assume there is. Work them out. So that being adding, we can also do scalar multiplication like we learned with our vectors. And so just like with scalar multiplication that we did with our vectors, I just multiply each and every term by that scalar number on the outside. So I would have 3 times 1 as my first blank, 2 times 3. Let me switch those numbers order-wise. So I have 3 times 2. And in my last spot, I would have 3 times 3. And so in the bottom row, I have 3 times 4, 3 times 5, and then 3 times 6. One thing I've noticed that helps me keep all of these straight when I'm working with multiplying or adding or subtracting or even some of the stuff we're going to do coming up, I think it helps for me to underline where my terms are so they don't blend together, because sometimes terms can blend together as you write them out. So I wrote really big on this problem, which was not a problem until I still haven't written my answer. So I'm going to come up top and write it. So that's going to be 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. In my bottom row, 3 times 4 is 12, 3 times 5 is 15, and 3 times 6 is 18. Once again, this one had a pattern because my numbers had a pattern in my matrix. They're not always going to increase by the same amount, so just do the multiplication. So the 0 matrix is going to consist of entirely zeros. So if I tell you, if I tell you I have a 0 matrix of order 2 by 3, that means I would have, actually let's change that order because we've been doing a lot of 2 by 3. What if I do 2 by 2? So when I do 2 by 2, it just means I have zeros as every single element. That's all that means. So it makes it pretty easy for us to go and use. Questions? Let me know if you have any. I know you kind of can't ask a question to a video. So, the additive inverse, and we'll talk about more matrices properties tomorrow because we are going to split this lesson into two. The additive inverse is going to be when things add to zero. Okay, so how do I add to zero? Well, so if my first entry had, if my first entry has a 1, what do I add to 1 to get it to go to 0? Well, my inverse of it would be -1 in that entry spot. Okay, and so B will be the additive inverse, consisting of when the entries, when I add them together, equal 0. So let's make a example so we can look at a matrix and its inverse, because I did not have one here. So let's go and look at if I give us the matrix A, and my entries are 3, 7, 9, and 2. So it's additive inverse. I want to add something to 3, 7, 9, and 2 that when I find out the entries, they all end up giving me zeros when I add them together. So the additive inverse, so that first matrix is A. The second one is B, which is my inverse. And then lastly, it equals the 0 matrix. Okay, so what do I add to 3 to get to 0? Well, since I'm adding, that would be -3. What do I add to 7 to get to 0? That's going to be -7. What do I add to 9 to get to 0? That's going to be -9. And what do I add to 2 to get to 0? That would be -2. So in this case, it's not hard to find the additive inverse. And so for that B, that is the additive inverse. Questions, comments, concerns? So today we are going to learn about multiplying, but we're not going to learn about how to calculate multiplicative inverses until tomorrow, because that lesson ends up being a little bit longer. So let's go talk about multiplying matrices. So these are better explained with examples. This slide is really great to explain how do I find each individual term of the matrix above up here. So Cij, each individual term will be added up this way, but I think an example helps make this clear because of how I'm going to show it to you. And so because of that, let's go ahead and look at an example so that we can see how we end up finding it. So first of all, notice that it mentions that it says find the product if it's possible. So what needs to happen for our order? We need to talk about the orders of these. So A is a 2 by 3 because I have 2 rows and 3 columns. But B has 3 rows and 2 columns. So these two do multiply together, and that's because the inside numbers match up. They have to match up in order for us to be able to multiply them together. And so the order of my matrix C, so remember AB, A times B, will equal a matrix C. So my order of matrix C is going to be these 2 outside numbers. So the first one comes from that first matrix, so C is going to be a 2 by 2. Okay, so that's going to get us started. Okay, so with that, I'm going to go ahead and I'm going to write my large matrix. That's going to include all of my work. Actually, I'm going to give myself a little bit more space. And it's going to equal my itty bitty matrix because it's just going to have my answer that doesn't take as much space up when I plug the numbers in. So these have a lot more work to show. So what we're going to do for the first row, first column, I'm going to use the first row from A and the second row from B. Okay, so I'm going to multiply 1 by 1 because they're both the first entries. So I'd have 1 times 1, and then we're going to add it to the second entry and both multiplied together. So 2 times 2. And then once again, we will multiply the third values together. So that would be plus 3 times 0. Okay, so in this case, I'm going to have 1 plus 4 plus 0. And all that equals 5 when I go and write it in that entry. Okay, so I'm going to go and erase all this stuff on the top from where I initially wrote these two. So remember, that's because this spot was the 1, 1 location. Well, this one is the 1, 2, first row, second column. So I will still use the first row, but I'm going to switch to using the second column to fill in that 1, 2 spot. So to do so, I'm going to go in and I will multiply 1 times 0 because they're the first ones. And then add it 2 times 1 because they're the second ones. And then add it to 3 times negative 1 because they're the third ones. So that's going to be 0 plus 2 minus 3. So that gives me negative 1. So now that I move on to the second row, this spot is the second row, first column, and this one over here on the other side would be the second row, second column. So when I go in to the top, I am going to go and erase the ones I highlighted and circled and dotted. I'm not going to underline this time, but I will highlight. I do think it's easier to highlight or hide with your finger when you're writing them down because it does make it a little bit easier. Because sometimes it is hard to figure out what am I using, what am I not using. I'm not really sure. So for this first one, I'm using the second row, first column. And so in the first matrix, you always use the row that you're on. And then for the second one, you're always using columns. So for this first one, I'm going to have 0 times 1 plus, we're out of order, 1 times 2. And I have a negative 1 times 0. So in this case, I have 0 plus 2 minus 0. So it's not 0. I had it wrong. So that's just going to be 2. Okay. So the only thing I have to erase up top, I'm not changing my row, I'm only changing my column. And so now I'm going to use that second column for that second row, second column item. So that's going to be 0 times 0 plus 1 times 1 plus negative 1 times negative 1. So that gives me 0 plus 1 plus 1, and that's going to equal 2. So that is how you go through and you multiply matrices together. So this is going to be the end of this lesson. Let me know if you have any questions or concerns. You'll go in and do 7.1 day 1 online. Hope you have a great day. Let me know if you need anything. Bye guys.